Okay, so for the first one, angles on a line equal 180 degrees. So if we take 180 and subtract the two angles we have, we'll be left with the third angle in the middle, which is 92 degrees. Okay. Next, angles on a point, what does that equal? 360 degrees. So we can do the same idea, but we subtract from 360. So we minus 90, this angle here, minus 60, this angle here, minus 32, this angle here, and minus 45, and the only one that's left over is angle CBA. Notice the order of the letters matter in the subtraction. B is the vertex. It should be your middle number. So 360 minus 90 minus 60 minus 32 minus 45. 133 degrees. Okay. Next one, triangle, angles in a triangle. What does that add to? 180. So we can subtract to figure out one of the unknown angles. And so what is our missing angle equal? 75 degrees. Hands up if you got that. Awesome. Okay. Then we start looking at our circles. So central to inscribed, if this is x, this is 2x. Okay. So the central equals 2 times the inscribed. And if you do that backwards, the inscribed equals central divided by 2. So they're both subtending arc GF. Okay. So they subtend or stands on GF. And we can say angle GEF is inscribed arc FEG. So going backwards around the circle is what the angle's technically inscribed in. Okay. So arc FEG. Good. Then we start talking about isosceles triangles, noting that you must mark radii as equal. Okay, so mark the radii as equal. So we can take 180 and we minus 40. That's going to be 140 degrees. Then we just divide it by 2. That equals 70 degrees. So each of these bottom angles have to be identical because that's the isosceles triangle. Okay. So an isosceles triangle has 2 equal slant sides and 2 equal base angles. And that allows us to find values only listing one dimension. So mark these two lines as being equal, either with 1 dash or 2 dashes. You can use 3 if you want, just must be the same. This then is also 25 degrees because they're opposite angles, opposite base angles. So the top angle then would be 180 minus 25 minus 25, which equals 130 degrees. Okay. Question, Dion? Just scratching the old noggin? Okay. We looked at 3 parts to the chord theory. So you must have a line from center. This line from center is called a radius or a diameter. That's important to know because I can get you to find area or circumference. Right, Kevin? Yes. Then what happens is a chord is bisected and so then what we get is the line is perpendicular to the chord. So we need to have a 90-degree symbol. Okay. We looked at the tangent rule yesterday, and the tangent rule and the line from center join at 90 degrees. So tangent is perpendicular to a line from center. Okay. Next one, equal out triangles. What do they have? Yeah, 3 equal sides and 3 equal angles, which happens to be 60 degrees, right? So it's going to be 180 divided by 3. Okay. What does subtends mean? To stand on. Okay. So the angles subtend arcs A, B, C. So we can say angle ACB subtends arc AB. And usually for arcs we put rainbows. Little rainbows on there because they're curved. Are you laughing at me for drawing a rainbow? I hope not. Different joke? Mm-hmm. Okay, bisects. What does bisects mean? Sorry, bisect. That's a CT. Means to cut in half. What does perpendicular mean? They join at 90 degrees or cross at 90 degrees, touch at 90 degrees, but it's 90 degrees. Okay? So you're talking about angles there. I can get. And last but not least, you got our favorite thing in the whole world is Pythagoras.
Is awesome.
So,
208.
yeah, I'm recording. So 64 I'm going to put there, 144 I'm going to put there, and what goes in the other square? 208?
Yeah.
Okay, so you're adding the squares. Okay, and then you have to square root 208. 14.4. And so that's our side length. Okay, that's another way of doing Pythagoras. If you want to draw all this, that's fine too. Or you can show your work like we did on our worksheets. Okay, and our quizzes and tests. Okay. Any questions? Okay.